Okay, on this problem it says the Hilltop Hotel has 2 elevators in the lobby. Elevator A is currently on the 25th floor and is descending at a rate of 5 floors per second. Elevator B is at the bottom floor. It is ascending at a rate of 5 floors for every 4 seconds. Now, so what they did was they took 5 divided by 4, and that's why they got 1.25 floors. It says, is there a time when the elevators are on the same floor at the same time? If so, when is it and on what floor? So the first thing it already wrote over there for us the equation for the second elevator. All right, there we go. For the first one, if my pen will write here, it's starting on the 25th floor and it is descending, so you're subtracting off 5 floors per second. That should have been the equation you came up with. Okay? So from here, to figure out when they're at the same time, see, these new smart boards are not very, very friendly. What you're going to do is go and get your calculator and put the 2 equations into your calculator. So in y1, you're going to put 25 minus 5x. There we go. Let's go here. 25 minus 5x. And in y2, the one they have is 1.25x, or they could have put 5 divided by 4, 5 over 4x. Now, when I press graph, you can look and see if you can see where it crosses. And in this case, we do get to see where the 2 lines intersect. So it has one solution. Okay? Sometimes you won't see it in this window. And there's different ways to be able to find your answer, and we'll talk about that in a minute. But I'm going to press second graph and look in the table. When I'm looking in a table, what am I looking for to see where they intersect? Where what? If y1 and y2 are the same. So I'm going to go down here. And right here, y1 and y2 are both 5. Okay, so my solution is actually 4, 5. So if I go over here, see if I can get the pen right so I can see it. If I go over here, my solution is 4, 5. But what does that mean? What does 4, 5 mean? What is x in this situation? The number of seconds. X is the number of seconds. And what is y? The floors that you're on. So this means that after 4 seconds, if I can write, seconds, they're both at the 5th floor. Okay? Now let's see if I can move this down and see the next thing. It says, write another system and use your calculator. And okay, well, we're not going to do that part. I want to move on today to go over the next stuff. Let's see what's on this video here. Oh, there we go. Here we go. This will start with our conversation here. If it'll play. Okay, talking about systems of equations. Okay, when you're trying to compare, like say you're trying to figure out, is it better to go with Verizon or T-Mobile, or even with T-Mobile, the different plans that they have. You're trying to figure out what's best and what helps you save the most money, right? So one of the way you do that is with systems of equations, and you can figure that out. See, it says you will receive, well, we're not going to receive the cards. We're going to talk about this. Plan A, if we go with Plan A for a phone, you're going to pay $100 for a new phone, which, by the way, is cheap, right? And $40 a month for service. So for my and the other plan, you're going to pay $70 for a new phone and $45 a month for service. Okay, the first thing we have to do before we write our equations is we need to define our variables. When they ask us to define our variables, because I have to know what I'm talking about, I'll go with X and Y. Okay? Y is going to equal my total cost. What's X equal? What do we have to pay for each time? Do you pay for the phone each month? The service fee, right? So we're going to pay, and X is going to be the number of months. Okay, so for Plan A, let's see, I'm going to say Y, and I'm going to kind of put A right there. That's going to say Plan A. First, you're going to buy the phone, and the phone is $100. Plus, you're going to pay $40 each month, right, for the phone. Now, Plan B, so I'll write it like this. Y equals with Plan B, I'm going to only pay $70 for the phone. But look what happens each month. I pay $45 each month. Okay, right now I want you to take in your calculators. I want you to put these into Y1 and Y2, and I want you to tell me when the plans are going to cost the same. When are the plans going to cost the same? They don't. Ever? No. All right, well, let's look. If we go to Y equals, we're going to put in there 100, plus 40x, 70, plus 45x. Now, when you first press graph, remember, we're only in that first quadrant. So all you see is those lines right there, right? It doesn't mean it doesn't ever intersect. You need to go and look. Now, we can look in the table by going to second graph, and you can search in the table to look and see where Y1 and Y2 are the same. So I'm going to look here, and I'm going to look in the positives, because if I go to the negatives for the X, can you pay for negative months for cell service? No, so you got to look in the positives. So I'm going to look here, and I can go through it this way and try and find where Y1 and Y2 are the same. Doesn't look like it happens, does it? At 6, oh, I'm blind. That's all right. I told you I'm an old crazy woman. Okay, so Y1 and Y2 right here are both the same at 340. So what that's telling me, so my solution is 6 and 340. They're going to keep asking you on your tests, what does that mean? What does the 6 and 340 mean? Remember, 6 is the number of months, and 340 is the total cost. So what it means is if you're only going to have the phone for 6 months, it says it's 6 months, both plans will cost $340. Okay? But really what you're looking at is this. Think about this when we're looking at it. Which plan is the best deal? And it depends on what you need your phone for, right? Do you only need it for 2 months? If 2 months is the deal, let's see, I'll go with 3 because it's on my screen. 3 months, right here. Which plan is better if I only needed my phone for 3 months? I don't know why you only need it for 3 months, but the second one, Y2, would be better, where the phone is cheaper at first, but it's a little bit more each month. But if you know you're going to have this phone way down the road, right? And you know you're going to have it for more than 6 months, which plan is a better deal? The first one. And see, this was kind of like yesterday's problem, because at first you're looking at only this first number, right? Because if you were trying to base your plan based off of how much the phone was, right? Say we're getting an iPhone for $100 at JoJo's store, and at Billy Bob's store the iPhone's $70. You're going to be like, whoop, whoop, I'm going to get it for $70, right? Because you're thinking you're getting a better deal. But are you getting a better deal if you have the phone for more than 6 months? If you go with Billy Bob or JoJo, I don't even know which name. My boyfriends, I get them all confused. JoJo, Billy Bob, Bobo, whatever. But do you see what I'm saying? Like it makes a difference, and you have to figure out what's going to work best for what you have. All right. We already compared. We compared. All right. Let's look at this. Here's a new scenario. It says, what information do you know from the graph? And it says, complete the table below. All right, I'm looking at this, and it's talking about, look at the x-axis. What's the x telling us? Okay, so the x is going to be the number of hours. Oh, that's not it. That's not the x column. Hello. This is the number of hours. And what is the y column? On my graph, what does it say it is? The temperature. So at hour 0, oh, and this is temperature. I'll change the colors. I'll make them the same colors on the graph. So this is the temperature, the red one. This will be the temperature of Montreal. The blue one will be the temperature in Vancouver. Let's look at the red line first. At time 0, what's the temperature in Montreal? 4 degrees. Which, by golly, it felt like that even here in Houston yesterday, just saying. All right. After 1 hour, Montreal was 3 degrees. What's happening to Montreal's temperature over the time? It's decreasing. It's going down. Now, wait a minute. Can I go in? Why is this graph? Can I go down into this quadrant right here? Let's talk about this for a second. I'm going down, and remember my quadrants go like this. 1, 2, 3, and 4. You know, normally we've only been in the first quadrant, right? Up here in quadrant 1. Why does it have these 2 quadrants right here only? Because temperature can be negative, right? Why is it not going over here to the second and third quadrant? Because the hours. We can't have -2 hours, right? So it's got to be both of these quadrants over here. So I can go, and why did I put a 4 up there? Why'd y'all let me put a 4? 1 and 0. I'm sure this is -1, -2. It seems to be steadily decreasing. Vancouver starts at 10 degrees. Let's see, this is decreasing a little bit faster. Goes down to 7. Goes down to 4, right? What am I missing? Oh, yeah, 2 and then 4, nothing. Okay. And then 3 and 1. And what am I looking? 4 and -2. 5 and -5. How long is it going to take for Vancouver and Montreal to be the same temperature? 3 hours, because right here, and you found that because Y1 and Y2 are the same. Okay? Now, in the solution, I found the solution just by filling out the table. That's 3, 1. And what does it mean? That means in 3 hours, both places, I'll just write over it, places are 1 degree. Now, what if we needed to write the equations? Because it says, what is the system of equations? So when it's talking about the systems, we need to write it. And I'm going to start with Montreal. Y equals. What's the y-intercept? Let's start with that first. The y-intercept, 4. And it's decreasing, so I'm going to subtract off. How's it changing? By what? It's changing. It's going down by 1. So 1x or just x. Vancouver, my y-intercept, it's starting up here at 10, and it's decreasing by what? It's decreasing by 3 degrees per hour. Okay, so my slope is the change in temperature per hour. All right, let's see what other thing they want to talk about. Okay, look at this situation. This is like, I think this is one of the last, let me see, I think this might be the last one. Yeah, we're not doing that one. Okay, so let me double check. This is the last one we're going to talk about. And then we're going to practice. This set, it has kennel costs. We got pet paws and barks a lot. Haha. Okay, got it. What situations are described in the table below? So when it's asking you what situations, they want you to write the equations for each one of these. Okay, so let's think about this. First off, pet's paws. I'm going to figure out what is my rate of change. What is it increasing by each day? It's increasing by 25. So I know my rate of change is 25x. X is the number of days. But what's my starting fee? If I go back here to 0 and I go back 25, what's my cost for 0 days? 0. Okay, so really I'm just going to write pet paws is 25x. Now, barks a lot. My rate of change is what? 20. So it's $20 per day. Now, if I go backwards, I have to go back to 0 to find my y-intercept. If I go back 20, it starts at 30. I'm not sure what that, maybe that $30 could be like a registration fee or something. Okay. All right, it says, which kennel seems to be a better deal? When you look at this right here, which one looks like it's a better deal? What would you choose? You're saying pet's paws? You're kind of looking at that thinking it'd be pet's paws. Okay. It says write the system, the cost over time. Oh, I guess I should have written those down there. Sorry. Let's see. Come down there. Oh, I didn't know I was going to break it all up. All right. So now I want you to go in your calculator. I want you to find the solution. Tell me when both places cost the same. Put those in there now, please. Go to y equals. Oh, let's see. So in y1, we're going to put 25x. And in y2, I'm going to put 20x plus 30. All right. You can go and look in your table by doing second graph, right? Watch this. Let's see if this works. This is the other way we can go through and start doing it, and it should give us our answer. You're going to go second, trace. See trace up there by graph? Press 5 for intersect. And press enter 3 times. But make sure it's graphed first. 1, 2, 3. Please don't tell me error. Oh, it doesn't. Look what it did. It told me intersection. 6 and 150. Is that what you found in your table? Okay. So look at this again. So you can look in the table and scroll through it and look for it, right? Or you may want to write down these steps because this will work and it'll take you to if your answers are decimals, it will give you the decimal answer. The table does not give you a decimal answer unless you change your table. Second, trace. 5 for intersect. Make sure the lines are graphed, otherwise it freezes your calculator. And press enter 3 times. 1, 2, 3. It gives you your intersection. If there's an error, I'll show you that later, but if it showed you an error and said for whatever reason it's not in the screen, you go to zoom and 3 and zoom out and press enter. and you would keep zooming out a couple times, and then you would do those same steps again, because the graph, the calculator has to see the two lines intersecting. So if it's way in a big number, sometimes you have to keep zooming out to make it work. Okay? One last thing I want to review with you in this, and I just want to remind you. Solving systems, when I ask for the answer, when I ask for a solution, there are 3 types of solutions. What are the types? What did we talk about yesterday? There's one solution, there's none, and infinitely many, or sometimes they just say many. Now, let's remember what those look like. One solution is where the two lines intersect, right? No solution, or what type of lines? Those are parallel lines. Infinitely many, it's one line, it's the same line. Now, what about the table? See, that's the other thing. If I have the table, nice lines, Crawford. Oh well. On my table, oh, I didn't mean to write that like that. X, try an X. Y1, Y2. Let's go 0, 2, 2. If there's one solution, there is one place where Y1 and Y2 are the same. If there are no solutions, that means that 0, 1, 2. There will be no place is Y1 equal to Y2. You will not be able to find any of them anywhere. Now, if there's many solutions, 0, 2, 2, 1, 3, 3, 4, oh no, 2, 4, 4. All the Y1s will equal Y2. Okay, when you're looking at the tables, because you don't know on the end of course exam or on your test if you're going to have to look at a graph and figure out the solution, or if you're going to have to figure out the table. This is one of the parts of the standards you have to do. Okay? All right, so let's go from here.